Hey folks, so in this video we're going to introduce the depth first search algorithm. So this is our first graph algorithm. This is a graph algorithm to basically explore a graph and figure out whether two things are connected. So this is how DFS works, right? So this is DFS, that's kind of the most common thing you'll hear. You won't hear depth first search, you'll hear just DFS because it's so common. So this is the basic idea. Start at a node. Mark it as visited. Once it's marked as visited, go and look at its neighbors and recursively explore them using DFS again, right? When they're not marked, explore them again, right? So there's just these two rules here, and that's really all there is to it, right? So start at a node, explore it. So start at a node, mark it, and then go visit all of its neighbors that aren't already marked, right? Repeat the process. So this is a recursive algorithm. This is very simple. And sometimes maybe it's too simple, but just to prove or to illustrate there, right, I have basically the entire algorithm here. So this entire algorithm would be written as this, right? So I have my DFS there, right? So I've marked a v equals true, count plus plus. This is the whole thing, right? And I guess let's spend just 1 minute. We'll trace through the code just a bit. So I take in basically two parameters, g and v. So it's like, well, what is the graph you're working in? That would be this thing over here, right? This is basically g. And then I have some node v, right? So maybe that's v equals 0. That's my graph and my starting position. Mark it as true, right? Maybe I do like a little marky thing on there. And then, right, I do count plus plus. Count as some variable somewhere, like counting how many nodes I've marked. Because remember, that's what I want for my problem, right? I wanted to return not only is something marked, but how many things, how many things did I count up as I was going through neighbors. And then I have my inner loop, and my inner loop basically just says this. It says, look at the current node v, look at its adjacency list, go through it, right? So go look at, for example, 1 and 3, right? Would be maybe my first thing I do. I look through that, right, and basically say, are these things not marked? If they're not, if I have a neighbor that's not marked, then I recursively call DFS on it, right? So I just do it again. So this is a very, well, this is I guess maybe a deceptively simple process, but it is one basically that is complete, right? So this is all the work we need to do. So you can view it in terms of this code, or you can view it in terms of this basic idea. They're the same thing, right? And if I follow this, basically I'll have a way to go and explore through every single element in my graph. Now in the next video, right, we're actually going to go and I'm going to work this basically as a sample problem, right, for you guys. You get some better intuition for how I move through the graph, because I know that right now it may not be that clear.